So today, we are going to talk a little bit about training evaluation. And this is just an issue that I thought it's important for you to know, because in any discussion on training science, you should at least have some knowledge about how to evaluate training programs or training systems that you see or design. So basically, training evaluation is about just like scoring or evaluating or assessing any training program or system or simulator or tool that you may encounter or you may design, and you want to just have like a gauge to compare between different training systems. So we have seen like psychological theories like identical elements or the belief in near transfer and far transfer, and we have seen the systems that were built upon those theories in different domains. So imagine you have one training system or simulator, and the question is that how do we evaluate the simulator? We already talked about things like transfer, like performance criteria, and the comparison between the performance or training effectiveness of different simulators. But here we want to consider more contextual factors and put it in a broad picture when we want to choose and evaluate training systems. So the key question is, what strategy do we employ when we want to compare between training programs? So it may seem simple to you by now, based on the discussion that we have so far had, that any training system or program that works better or has a better transfer is simply better. But today we're going to see that it's not as simple as that. If we want to compare between different systems, we have to consider other factors as well. For example, if you think of troubleshooting, we saw in previous weeks that we have the options of using this low fidelity simulator that we saw how it worked. And also we saw another example, a little bit higher fidelity, slightly different. And finally, this more higher fidelity system that had the specific information about the mechanical system and this interface as a control panel. So the question is, which one is objectively better? We said that the first one had better performance, considering that it was like lower fidelity. It could be generalized to many real-world tasks, but we cannot still say that which one is better in all situations. Because if you consider this one, maybe this works the best for that particular system that we want to train people to troubleshoot that system. And the performance of this one might be better than the other two. So the question of which one is objectively better, we have to consider other factors. Or if you consider another task that we gave the example of, like stone removal from kidney, that's surgery, we have the option of using the low fidelity materials and the higher fidelity materials, more expensive. And we saw compared their performance. The higher fidelity was slightly better, not significantly better, but even that slight difference, we cannot say which one is the one that we should choose just by considering their performance. We have to consider other factors. And the question is, what factors should we pay attention to? Or what should we think about when we want to choose a specific training simulator for a specific task. Yes. Mm-hmm. Yes. So exactly, the organizational considerations, which do not just care about the difference in performance of each training simulator or the difference in their transfer rate, that's one factor. But there are other factors like the ease of access or the costs associated with using the simulator, its long-term maintenance costs, and whether that should be replaced in 5 years or updated in 5 years, or it's just like a system that is abstract enough that does not need replacement for 50 years, say. So these are some organizational considerations that we should have when we want to choose a simulator. Any other factors?
I mean, I would say main factors. This is sort of similar to when you talked about main factors. Amount of resources available. So that would be factors like money available, employees available, other resources such as like office supplies, things like that.
Mm-hmm. Yes. Yes, exactly. For example, if you have a training simulator that needs supervisors or experts, then the question is, do we have access to those experts? Or is it cost efficient for us to employ experts for training that particular task, or we do not have those resources, or even if we do, whether we want to spend that much resources on training that task. Yes.
I would say you don't have how much error.
Mm-hmm. Yes, exactly. Like, to what extent the precision or the accuracy of the training materials matter for that task. If it's like critical tasks, like flying an airplane or defense sector or defense tools, then they are critical systems. Even the slightest error can be crucial. But we can think about tasks that you have more freedom in how you can train them. So you choose the less costly one or the simpler system for that.
How long you could wait for the new batch of experts? Like, when do you need them? Like, if you can wait for a long time, that means like those experts supposed to have them, perhaps you could start with like, fidelity one and quality one.
Mm-hmm.
But if you like, need them like right away, perhaps the kind of fidelity one will be possible.
Mm-hmm. Yes, the amount of time or temporal considerations that we can have, how much time we can or we want to spend on training, and whether we can accelerate that by employing experts or not, or if it's like there are different systems that each of them take certain amount of time for training, which one we should choose. And so it's kind of an optimization task of choosing between systems based on all of these limitations and factors. Any other thought? Yes.
And you notice that money for someone to have to sort of need the same level of detail as the doctor.
Yes. Which I think is related to some discussions that we had about knowing the characteristics of trainees and knowing who and for what task the training is being designed to, and even critical questions like whether we need a training simulator for training this task or not.
And I think that as part of the stage of the training is important. For example, if you're in the beginning of the stage, then a low fidelity would be better than if you're at the end of the stage.
Yes. So choosing a specific simulator also depends on this trainees needs analysis or knowing about trainees characteristics and what particular level of fidelity is more helpful for them.
I think also depend on how we use the simulator. Say resources for the company, like
Yes. So we can have like situations in which using a simulator or a session of a simulator has X amount of costs. And so you have to decide how you want to spend resources on using training simulators, especially in the military and about more expensive training simulators. But otherwise, we can have like most of the training programs are not as expensive to use, and then you can just use them anytime, just without spending more on each usage. So these are all the considerations, and we'll talk about them more in detail. And so we can have different strategies to know about these factors, because just to think about them and brainstorming about them, it may look a bit confusing, because then you would ask, like, how should I start? So one strategy is to start from ourselves, like training designers or training psychologists or training scientists. And we can say, well, we designed a training simulator and we know how it's working or how well it's working. Or we designed 3 simulators and we want to compare between them, and we think we might have an accurate idea in evaluating them. So we have these systems that we are designers of those systems, and we observe how trainees are using them. Simple observation or video recording or just being in that environment and having a form or anything that we can record how those training systems are being used. So there are some advantages to this strategy. And one thing is this idea of usability test, that you design a product, anything, including training system, and you send it to its users, and you observe how they are being used, and you can understand its usability. You can see how users or trainees start using them, what are the components that are being used, what are the things that are not necessary. So you can find about the details of your design. And you can have a direct access to how engaging the users are, how they're spending their time. So if you, as a designer, want to evaluate your own system, these are the benefits of direct observation. But it also has its disadvantages too. The problem is, as we talked about this before, we do not know how to, because we are not, like, we may not be expert in that task itself. We do not know what's the best strategy to train them. And so that lack of knowledge does not allow us to have a accurate evaluation of the training simulator. Another thing that we do not know is that, imagine they learned certain skills, they got better in those skills, but we designed the system and we haven't tested it on whether those skills transfer to the target environment. That's another thing we do not know. And we have to know that by conducting experiments and analyzing the results. So transfer is another thing that we do not know. These are two, at least these two factors are the problems in evaluating from the perspective of training designers. Another strategy, so the first one was you're the designer, you evaluate. The second strategy is by asking trainees. So you have a number of training simulators, different simulators, and you make trainees use them, develop skills by them for some time. And after that, you go to those trainees, you ask them, how did you like it? Was it engaging? Was it fun? Did you like it? Do you think it helps you? Do you think you're developing new skills by using that? So that's another group of people that you have direct access to, and you can basically spend some time, know about their own experience, trainees' experience with using the system. So that can be done through survey or interview, or just asking them questions that you can know about their experience. So one advantage of this method or this strategy is that you can, at least one thing that you can learn is that whether they enjoyed their own experience or not, whether the training materials were engaging enough. Of course, you don't want to have a simulator that looks boring or does not engage trainees, even though it may be effective, but when it doesn't engage trainees, it's not useful. So that's one window to know whether it is engaging enough. But it has also its own problems. That, again, as we talked about this before, trainees do not always know what's good for them or what they should do to develop skills that are used in the target task and environment. And they also do not know about the transfer itself. That, okay, now I got better in this simulation or in this game. But whether my improvement or my skill in this game applies to anything or not, it's just, I got better in this game. This is another thing that trainees do not know. So we saw two strategies. One, just you as a designer evaluate systems directly. The second one was by asking trainees about their experience. And this asking trainees is just, in a parenthesis, it's just like when you evaluate your instructors in college or university. So they ask you whether you like the class, whether it was engaging, whether you think it helps you in future or not. To some extent, it can be used because if there is like a major issue or problem with a class or with an instructor, and the majority of the students are pointing to one thing, it may raise some concern. But it has its own problems because, again, students do not always know what's the trajectory of their learning or how they should be guided towards learning certain materials. So they may not particularly, or at least some of them, may not enjoy certain topics, but if they get engaged and they learn those materials, then it may be useful for them. So by that, I mean, students do not always know 100% what's the best for them. So this is one problem, and it's just like what we talked about evaluating training simulators, that trainees are not the best or do not have the final answer on whether the system is working or is being beneficial for them or not. So the third strategy is asking experts. So we had training designers, trainees, and now experts, the three human sides of a training program. So in this strategy, we asked experts, which training program do you think is better? And this is also through survey or interview. After experts made an assessment on certain number of simulators. So one key thing that we can get, or the benefit of using experts for this goal, is that at least experts can tell us whether this simulator or this training material contains the important task or the key task and the goal of that task, whether it has those critical components or not. Because at least as experts, they know what's the goal and what are the required tools for a task. That's what we can learn from experts in evaluating systems. But again, just like the other two group of people, we cannot depend on them 100% because just like what we talked about before, experts do not always know how to train their own skills. They are experts, but they are not training scientists. And they do not know how other people can develop the skills they have. And they also do not know about many other factors, like whether this training simulator is engaging enough or not. They themselves know the task. They know, okay, this is designed because it is replicating the target system, but they cannot necessarily evaluate its engagement. And also they do not know about the transfer. They cannot give an accurate comment about the transfer as long as we do not have the results of an experiment. So as you can see, all of these three groups of people are giving us some information that is unique to their own experience. So the usability test, or test of how training systems were used, comes from the training designers and their observations. How engaging the training can be is what we can learn from by asking trainees, and whether the training program or training simulator contains the key components and elements of a task is something that we can learn from experts. But they all had their deficiencies or their problems or cons. So all of these three strategies had pros and cons. Do you have any question about whatever we talked about by now? Yes.
So it seems like for just about all three strategies, still left with the fact that we don't know if the transfer is possible.
Yes. That's one thing that we're going to talk about in coming slides, that one of the things that we are missing from this whole focusing on the human side and not conducting experiment is that we do not know about transfer. And that's only one of the factors that are missing. Even if we know about transfer, we still need more information in training evaluation. Any other question? Yes.
What do you? Well, then potentially with the we get the best result, we find the best pros and cons.
So can you please repeat your?
What the best result would just be using all three strategies then potentially?
Yes, that's exactly what we're going to talk about in next slide. And so the question would be, what if we combine our knowledge from all the three group of people that we talked about? So that's the question, that all of those strategies have pros and cons, and we can use all of them. So all of these group of people, if we have access to all of them, designers, trainees, and experts. The question is, that's the question that I have from you now, that whether it's a good idea or whether it answers all of our questions or whether we should do that or not, what do you think?
I think that it's a better idea than the first three strategies, because the first three strategies, they left gaps, and if you overlap them, they cover some of the gaps. They're still missing the one major issue, load transfer. They're still not perfect, but it's definitely better.
Yes, so each of them are giving us some new information that they only know. So if we combine this knowledge, we have at least a more comprehensive knowledge, which may not be enough, but still is something that would help us in our final decision. Any other? So, yeah, it is a good idea to have, if we have access to, for example, experts and trainees, it is a good idea to use their knowledge and their experience and their insight, because we can get new information from them. But it may not be enough, just like the transfer that we talked about. And beside that transfer, before that, I also want to mention another factor that is missing, and that is the costs, the accurate cost of developing, implementing, maintaining, and whether the training benefit they have is worth those costs or not. So it's kind of a analysis of cost effectiveness. So if you want to, you may ask, okay, what about, I mean, designers should know about the cost, but no. I mean, if you think about the definition of designer in even as job titles, designers usually are not necessarily developers. And even developers may not have an accurate idea about the costs. So neither of these three groups are expected to know about the costs. They may have some ideas, but they are not expert in that. Maybe senior engineers or managers may have a clear idea about the costs. So we need input from them, from these three groups of people, plus cost-benefit analysis. And well, the answer to this question, we slightly covered it already. But imagine we have this information. What is missing? One thing is the knowledge of transfer. Any other thought? Yes.
How long do you can get a simulator? So I think it doesn't make it simulated necessarily, but it really
So that's the issue of accessibility to what range of simulators that you're considering. That there are many private companies, for example, they're all developing and selling their own training systems and simulators, and you may not have a universal knowledge of what exists in the world for training this specific task. And that's another issue about the limitation of your knowledge about what's out there. Yes, William?
Yeah, my reply was going to say, it seems like the gentleman that is I think we want to pursue
Yes, exactly. I mean, we're going to talk about that, but I mean, these are more contextual factors that you have to consider. Ahmed?
I was going to say, like, time, how quickly somebody is able to pick up the knowledge.
You mean the individual differences in trainees learning?
Yeah, like evaluating somebody, how quickly they can do the skills, spending time on something.
Yeah. So yeah, these like time factors and temporal factors are the things that we talked about. They all are playing a role, but if we want to continue on this, of course, the answer is no, just because of these factors that we talked about. And first of all, we do not know about the transfer. That's one factor that you have to consider in comparing training system. That's probably one of the first things that came to your mind when I said comparing simulators, for example. But as a general thing, like these factors that you mentioned, also like temporal issues and other issues. So if you think about it more, you can find more and more factors that you have to think about in choosing a simulator, in evaluating. But this is a bit confusing because then the question is, okay, do we have to pay attention to all of these factors, like 20, 30, 40 factors? It makes it too complicated to just choose one simulator among the options that you have. And so there should be a way to get around this confusion. There should be some kind of a strategy. So what we need is that some method or some model or some strategy that has certain steps, and we have to follow those steps in order so that we can at least have some guideline, that we are not left to think about factors forever. So this is kind of justifying the need to have a strategy for training evaluation. So now we're going to talk about one famous example of these strategies, or they call it model, but it's basically the same strategy that shows us some step-by-step the steps that we have to follow to do the evaluation. And it's broad, it's general, it can be generalized to many or almost all training systems. And so Donald Kirkpatrick is the figure, the famous figure behind this model. And I think in mid-90s, he and his collaborator introduced this 4-step model of Kirkpatrick's training evaluation strategy. So he proposed 4 general steps in evaluating any training simulator approach. So it applies to our discussion on training systems and simulators, but also to even instructions. Like imagine you have a product and you write down the instructions of how to use that product. You have different ways to write down that instruction, and even evaluating that in instructional science. You can also follow this training evaluation strategy. So it is known as Kirkpatrick's 4-level model of training evaluation. And these 4 steps should be followed in order. So the first one, the first thing that you have to do is to assess the reaction. And what it means by reaction is that, just like one factor that we talked about, it is trainees' engagement with the simulator. So we haven't talked about this factor in this class so far in detail, but it's one of the important, or here, as you can see, it's the first step, that if there are training materials that are not engaging, if there's a video game or anything as a simulator, and it's not an engaging video game for the trainees, it doesn't work. And even if it has high transfer rate, still, it is not considered as a training system that we can use. So the first thing that you have to check is whether that certain training simulator or system or tool can engage trainees. Now, there are certain strategies to create this engagement, which is itself another topic, but suffice it to say that it has to be engaging. And so by that, it means that trainees should find it enjoyable. They should have fun using that, in plain terms or in common terms. And another thing is that they should be convinced that it's not just some kind of a useless activity or something that is just not useful, but they have to be convinced that their practice with those materials is helping them or preparing them to acquire those skills that are needed for the target task or environment. So these are 2 representations of what it means by being engaging. So the first step or first level is called reaction, or the immediate reaction of trainees when they face the training system. If their first reaction is negative, it's difficult to continue and get good training benefits of that simulator. And that's why it's the first step. So the second level or second step is called learning, or in our parlance, training. And this is the level that is focused more on the general knowledge that trainees need to have for a specific task. And so it first focuses on the specific knowledge, skills, or the kind of knowledge like what's the goal of this task, or what are the required tools. And it may be to some extent task specific, because some tasks require more knowledge, some other tasks may not require that much knowledge. It's just like simple tools, but then to use those simple tools, it may require more and more practice or complex skills. But generally speaking, it's just, for example, if it's flying an airplane, then what are the basic principles or basic parts of an airplane? That knowledge is a basic knowledge that all pilots should have. Or the working of general or basic working of human body for people in medical or medical professional. That's the second level that they have to learn these steps.
Would it be like better to have lower prerequisites?
It depends on the domain. So you cannot basically compare. I'm thinking of whether there are situations that you have the option, but if you selected certain domain like medical domain or flying an airplane or anything like that, there are some basic knowledge that should be learned. And so that's the basic requirement. That's the prerequisite. And that this is focusing on that part. So this level 2 learning, it's about examples that I just talked about. It's about the objective, the goal of that task. And it also focuses on, for example, practicing with that task, how much practicing with that specific task changes the skill of trainees. So you might have a task that practicing that task doesn't change anything in trainees. They basically do not learn anything new or do not acquire a new skill. But you can have other tasks that you know, at least for this specific training material, they're learning something new. Even if it's a game, they're getting better at that game. So that's about learning basic things and whether they are learning something new or not, just to make sure. So the first one was reaction, the second is learning. The third of the 4 level is behavior. And by behavior, it means transfer, basically. Whether whatever is being learned and trained, the general knowledge or whatever is skills, trainees acquire, whether they transfer to the target environment, target task. So this has been the focus of a lot of our discussions before. It's basically transfer. In this model, it is referred to as behavior, but by behavior, it means like external representations of people's performance in the target environment. And so should be a typo. So it's basically level. Oh, no, it's not typo, it's right. So level 2, just as we talked about, measured how much the training adds to trainees' skill, whether it applies to the target environment or not. But here in level 3, we want to make sure whether that skill or that knowledge that was acquired, whether that can be transferred to the target environment. So it's not just about learning, but whether your learning is helpful. And there can be a situation that trainees get better in the training task, but not in the target task. And that's where the transfer is not high or it does not exist. Yeah, so this level 3 is designed to make sure transfer is happening. And finally, level 4. And level 4 includes that discussion of cost effectiveness. And it also includes that discussion of organizational considerations. And it's just basically the overall assessment or overall result of having a simulator with all the contextual organizational factors involved. It's like issues that we do not address in short term, like long-term retention of skills, whether training with that certain simulator has a long-term benefit. And issues like ROI or return of investment, which is what we talked about, whether an organization is willing to pay a certain amount of cost for a certain amount of money for a simulator and whether that cost makes sense. So based on these 4 levels, we have this kind of pyramid that starts from level 1 and goes up. And so if you do not satisfy lower levels, you cannot go higher. If you do not have a good reaction or engagement with a simulator, you shouldn't focus on whether it has a good transfer or not, because it doesn't matter. And the same applies to learning. If they do not know the basic working of the system or the basic goal of the task, then having a higher transfer doesn't matter. And even if it has a high transfer, it results in the kind of behavioral change that is needed in the target system. Still, it may not be the best simulator to use because it may be too expensive. Or it may take too long to use that specific simulator for training. So as you can see, we were thinking about factors, brainstorming, which seemed a bit confusing because we were adding more and more and more factors. But this is showing us a kind of a direction that categorize all of those factors into these 4 steps. It is kind of a guide in training evaluation. Do you have any question about the Kirkpatrick's model? So, as I said, these 4 steps should be followed in order, in certain order. If you're not finished with one step, you shouldn't go higher. Should not go to the next step. And also, we want to talk like briefly in the end about the benefits of having this 4-level model. As I said, the first benefit is that it shows us the steps and directions. You're no longer confused in the number of factors that we have to consider. And just like low fidelity training simulators, it is abstract and generalizable. So you can basically, because it doesn't go through the details and specifics, you can apply this model to evaluate simulators or training programs in almost any domain and in any level. But there are also limitations to this Kirkpatrick's model. And some researchers argued that this level 2 may be removed, at least for a lot of tasks. Because if you have like level 1, 3, and 4, you have like their immediate reaction, you check their transfer, and then organizational performance, especially for tasks that do not need that much basic knowledge of the system. So it's like whether they already know about the basic principles or basic knowledge of the system, it's simple, then you do not need level 2. And being abstract is good because it's generalizable, but it's also not good because if you have specific simulators, then it may not be of that much use. It's good for like broad organizational considerations, but for comparing between specific simulators, there are a lot of other complicated issues that happen, and this model does not address those. As an example, there are, for example, one thing is measuring the transfer of skill between the target and between the training environment and the target environment, and to put that in a numerical order. That's one of the traditional problems of training in many domains. How do you quantify and measure the transfer? And if you want to compare between different simulators, you have to know the transfer rate in terms of numbers, because you have to compare. And this doesn't solve the problem. So it is, as a general guideline, it is helpful. As an organizational guideline, it is helpful, but it may not help us in the specifics of comparison.